हेलो बच्चों, चलो आज हम पढ़ते हैं वर्क. दैट्स सेकेंड चैप्टर. व्हाट इज देयर इन वर्क? काम. काम सब लोग करते हैं, मैं भी करता हूँ, आप भी करते हो, काम करना. बट हमारा फिजिक्स की लैंग्वेज में वर्क कुछ अलग होता है और हम जो जनरल लैंग्वेज में बोलते हैं वर्क कुछ अलग होता है. वी यूजुअली से that I'm very tired because I did a lot of work, whereas actually in language of physics I may not be done some work. For example, it's a very stupid kind of example, right? A colleague having a box on the head is moving and our physics says work is zero, no work is done. That's such a stupid example, but what to do? According to physics, work is something different. Work is not what we see all around. According to physics, work we do always by a force or against a force. Work is always done by a force or against a force. A force is always involved in the work. So now you will say the force is also involved here. The weight of the box is also involved here, right? The force is involved. But the another thing what we say in the physics, the motion should not be perpendicular to force. The motion should not be perpendicular to force. So there are two things which come out when we say the work is done, right? So when we say work is done, in a very simple language, work is said to be done. Work is said to be done if object moves in any direction except perpendicular to force. Except perpendicular to force. So the one thing, the motion should be there, displacement must be there. Basically the displacement must be there. And displacement of what? Displacement of point of application. Displacement of point of application of force. What does it mean? At which point the force is applied, that point must move, and that to move in any direction but not perpendicular to force. So remember this, work will be said only when an object move in any direction but not perpendicular to force, right? So how we calculate the work? How we calculate the work? In general, what we say, work W is equal to force into displacement of point of application of force. Displacement of point of application of force. And it is quite simple. If the object is moving in the direction the force is applied, the force is applied and the object moved by a distance s. So we say the work is F into S. What? If there is some angle between force and distance, displacement, means force is not applied in direction of motion. Force is applied at certain other angle. कुछ किसी और एंगल पे अगर हमने फोर्स लगाई है, then work कितना होगा? So we have two different way to calculate that work, right? So let me tell you one by one. So till now what we have studied, work is said to be done if actual displacement is there, but if the displacement should not be in direction of motion. Displacement should be not be in direction perpendicular to motion. Let us take an example. It is an inclined plane. an object move a distance s along this plane. An object move a displacement s along this plane. This is what? Horizontal. And we have applied a force like this. A force is applied like this, and this angle is theta. This angle is theta. So we have two ways to calculate the force. First, the first way, what we do, we take the displacement in direction of force. So if this is s, and we will use a small trigonometry, that this will be s cos theta. So what we will do, we will take this displacement. We will take this displacement, and this displacement is how much? S cos theta. So the work will be F into S cos theta. In a simple language, we can write work is force into displacement in direction of force. Displacement in direction of force. हम इसको बोल सकते हैं component of displacement. We can say the component of displacement in direction of force. So what we get? An angle here. The angle is theta. What if theta is 90 degree? We all know cos 90 is equal to 0. So work is equal to 0. This is what I said. A pulley, a box, the weight, and the pulley is going in this direction. So displacement and the force are perpendicular to each other. So there is no work done by pulley. Correct? So that is one way to calculate the work. How? You take the force and component of displacement in direction of force. The other way, on the same example. The other way on the same example, this is what our object, this is what is the force applied, and the object moved to this position, the displacement is s and the angle is theta. Okay? Now, what we can do is we can make the component of force. We have two options. Either we have component of displacement, which we did in our first method, or we have the option to make component of force. So if I make the component of force, then the component of force will be like this, because if this angle is theta, this is also theta, and the component of force like this. This component is called F sin theta, and this component is F cos theta, right? If you will see, this force is perpendicular to displacement. This force is perpendicular to displacement. So this is not going to do any work. So which part of the force is going to do work? Only this part of force is going to do work, right? So that is how we are calculating work, by using the component, because we know that if a force is perpendicular, then that is not going to do work. So only this part is going to do work. So what we can say in this case, the work is, the second case, work is F cos theta into S. Again, it is same Fs cos theta. We can write component of force, by making component of force, then component of force into displacement. The previous one, this. by taking component of displacement. By taking component of displacement, in this case also if we see, this is s cos theta and this component of the displacement is s sin theta. So this component is not going to do any work. So there is no work because of this component. So in general what we get, work done is equal to Fs cos theta. When work is 0, वर्क 0 कब होगा? फर्स्ट s is equal to 0, second cos theta is equal to 0, that is theta is equal to 90 degree, right? So there are two conditions when there is work, when work done is 0. One, either displacement is not there or force and displacement are perpendicular to each other. So अगर displacement नहीं है कैसे? I go and keep on pushing the wall. What happened? The wall will not be pushed. The wall will not be displaced. So in language of physics, I didn't do any work. In language of physics, work है ही नहीं, right? We studied one centripetal force. What is centripetal force? This is centripetal force. What is direction of motion? This is direction of motion. So what is the angle between force and direction of motion? The angle is 90 degree. So what do you say? If the work will be there, if the angle is 90 degree, so will the work will be there? No, there will be no work. So make it sure, one, displacement must be there. Second, angle between displacement and force should not be 90 degree. And remember, what you need to check? Point displacement of point of application of force. Now, the unit of work. Work, first, is a scalar quantity. Work is a scalar quantity. Force is a vector, displacement is a vector. So product of two vector is a scalar. Interesting? So W is equal to force and displacement. ये भी vector, तो इसको हम बोलते हैं dot product. In fact, जो vector quantities होती हैं, उनके दो different type of products होते हैं. One is called the dot product and one is called the cross product. The dot product also called as scalar product. In this product, when we multiply two vector quantity to each other, then they result in a scalar quantity. And in fact, this dot product means Fs cos theta. So the numerical the value of this is this. So work is scalar. Work may be positive, negative or 0. I'll show you some example of the positive work and the negative work. Work may be positive, negative or 0. Third, unit of work. SI unit is joule. CGS unit is erg. 1 joule is equal to 10 to the power 7 erg. So that is the unit of work, right? Now I take one of the example and calculate work done by different forces involved in the system, right? So that you can understand how to calculate work by the different forces. Okay, so let me take one of the example. One of the example is, let's take the work example of an inclined plane. An object moved, an object of mass m moved by a distance s on an inclined plane. The angle is theta. we applied a force F, there is a friction force F, there is weight mg, and let's say this height is h. The object moved to height h. Okay, so first let's calculate, let's see how many forces are involved. The forces involved are F, external force, F, friction, and weight mg. So let us calculate work done by each and every force one by one. वन बाई वन एक एक फोर्स का वर्क कैलकुलेट करते हैं. ठीक, फर्स्ट वर्क बाय अप्लाइड फोर्स, जो फोर्स हमने अप्लाई की, लेट्स से इट W. अकॉर्डिंग टू रिलेशन फोर्स इनटू डिस्प्लेसमेंट in direction of force, या displacement and component of force in direction of displacement. So here the force and displacement both are in same direction, so F into S into cos 0. So this is simply Fs. Second, work by friction W2, the force, displacement, the force and displacement, the angle between force and displacement is 180 degree, because force is downward and displacement is upward. Friction is always opposite to motion, so friction is downward and displacement is upward. So work done by friction is Fs cos 180 degree, because angle between them is 180 degrees, so we can write minus Fs. Okay, the third and the third. The work by the weight W3 is equal to the weight, and it is displaced to this position. It has displaced to this position, from this position to this position. So this is the direction of force, and along the force the displacement is h, the weight is downward, height is upward. So हम क्या लेते हैं, displacement along force. So displacement along force is what? H, because both are opposite to each other. So work done is minus mgh, and the total work done is sum of all. So total work done on the body is work done by all. To calculate this work, we have another way. What? Let's take the component of force. If we take the component of force, this will come as mg sin theta, right? So we can also calculate W3 is equal to mg sin theta into S, but negative. Why negative? Because mg sin theta is in this direction and displacement is in this direction. Further, we can write h is equal to S sin theta. So W3 is equal to minus mgh. So you get this way or that way, obviously the work will be same. If that's very true, the object doesn't know how we are calculating. The work तो जितना होना है उतना ही होना है, चाहे हम किसी भी तरह से कैलकुलेट करें. ऐसा तो हो नहीं सकता, दो डिफरेंट तरीके से कैलकुलेट करेंगे तो दो डिफरेंट वर्क की कैलकुलेशन आएगी, राइट? Let's take one more example. This is an object of mass. We all know the weight will be there. I want to lift it to a height h. I want to lift it to height h. I want to lift this object to height h. If I want to lift it, I need to apply a force. How much force minimum I need to apply? Minimum force I need to apply this weight is equal to mg. So F minimum should be equal to weight. So now if I calculate work by F, W1 is equal to F into H, and if I calculate work by weight, W2 is equal to the weight into height but negative. Why negative? Because weight is downward and height is upward. So the total work is F into H minus mgh. This all will depend how much force you applied. If you apply the force mg, then if you apply the force mg, then W is equal to 0, right? Because this mg h and mgh will cancel out, then work done is 0. Now the question is, why work done is 0 in this case? Look for this. This is an object on my hand. I raise it up, but it did not get any velocity. Because it did not get any velocity, so the work is not done at all on the system. The work is not done at all in the system because the net force on the system is 0, right? If there is no acceleration of the object will not get velocity, and will not get velocity, तो velocity change नहीं होगा, तो work भी नहीं होगा. That's all for the work. We'll continue in the next video. Thank you.